Hey gang, Mr. Cruze here. Welcome back. This is the Chapter 11B review, Day 2. Again, you can always Twitter me at Mr. Cruze Math, email me ccruze@brownsburg.k12.in.us, or post a comment on this video if you have any further questions. I will also be here in the morning as well. Alright? Let's finish up this review. What do you say? Number 13 has us find the mean, median, and mode of each set of values. Probably a good idea to rearrange your data values. So we have, let's see, 79. 82, this probably is the hardest part. 87, I think, is the next one. Let's see, 91. There's a 93. There's two 97s. Okay, a 98. A 99. 100, 1, and 102. See, I started with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers, and I ended up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. For mean, I went ahead and took the liberty of adding them up beforehand. The mean, when you add them all up, you get 1026. You divide by 11 numbers, and you get a mean of 93.3, roughly. The median is the very middle number. So since there are 11 numbers, 1, 2, 3, 4, 5, this number is in the very middle. There are 5 numbers above it and 5 numbers below it, so it's 97. And the mode is, of course, the most common number, which is 97, so they happen to be the same here. It won't always happen. Range and interquartile range. This one just takes a little bit of time. I went ahead and rearranged them before the recording. This is kind of interesting. Actually, I think some of you were pointing out this is actually the same as the day 1 review, but you might not notice that. Anyway, the range, you take highest minus lowest. Well, the highest number is 32, the lowest number is 2, so you get 30. So the range is actually pretty easy to get. It's interquartile range. It's a little bit more of a bear. There are 26 numbers, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's going to be halfway between 10 and 11. 10.5 is Q2. Then you look at your bottom half of your data, okay? And I did this earlier, and it looked extra ridiculous. Let's ignore the bottom half of your data. What's the median of this half? Well, there's 13 numbers, 3, 4, 5, 6. So it'll be this number, 6. Okay? So Q1 is 6, right? Let's do the same with the upper half. Find the median of the upper half. 2, 3, 4, 5, 6. I think it's 15. So you see those two outer numbers I circled? For interquartile range, you take 15 minus 6, and you get 9. Okay? The one on your test will not be that long. Okay? Find the outlier. Oh, let's rearrange our data. 1, 5, 8. Nope, 8's not it. 6, then 8, 2 13s, a 15, and a 33. Is that all the numbers? Yep. Which one of these is too far away? Well, probably not the one. It's only 4 away. But the 15 is actually 18 away from the 33, so 33 is the outlier. Okay? Box and whisker plot on number 16 isn't so bad. Let's see, I rearranged the data. 12, 13, 16, 17, 22, 27, 29, 35. Box and whisker plot, well, it has me put a dot at 12. I think I went up by 2s. Oh, dot. Here's 10. We'll go by 2s. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. 32, 34, 36, 38, 40, and I think that's all we really need. Dot at 12, that's the lowest number. Dot at 35, that's the highest number, so let's see, that'll be right there. Median, there are 8 numbers, so it'll be halfway between 17 and 22, which is 19.5. So I put a bar at 19.5. Look at the lower half of your data. The median is going to be between 13 and 16. That'd be 14.5. So I put a bar at 14.5. Upper half, it'll be between 27 and 29, which is 28. So I put a bar there at 28. And I connect my box. And I make my whiskers to the dots, and boom, box and whisker plot. You basically need lowest number, Q1, Q2, Q3, and the highest number. Mean, variance, and standard deviation. Oh, I'm gonna go to a different table. Okay, so here's our table. I rearranged the data lowest to highest. Let's find the mean first. So we add them all up and divide by the number of numbers, which is 6. I get a mean of 34. Okay. A mean of 34. Somebody check me on that. Everything looks good. All right. Yep, it does work out. So we have to do 26 minus 34. We get negative 8. 27 minus 34 is negative 7. 30 minus 34 is negative 4. We have 0. We have 8. And we have, what is that, 11, right? You square those numbers. We have 64, 49, 16, 0, 64, and 121. And basically, you're going to find the average of these numbers on the far end. You're going to add them all up. You get 314. And you're going to divide by the number of numbers, which was 6. And that'll get you your variance, which is 52.33. That's your variance. We already have the mean. We have the variance. Now we just need, maybe I should write it on the actual worksheet. Now you just need standard deviation. Well, standard deviation is the square root of the variance. So you take the square root of 52.33, and you should get 7.23. And there's your answers. Okay. Number 18, within how many standard deviations of the mean do all the data values fall? I look for the smallest and the highest number. Smallest is 26, highest is 36. And then I keep adding standard deviations until we get outside those range on both ends. So I'm going to add and subtract 3.2. This one you get 33.5. Going this way, you get 27.1. Still not small enough and big enough. So I need to go again, minus another 3.2, and add another 3.2. Alright? So this way is now 23.9. Hey, that checks out. That's smaller than 26. This one is 36.7, which is bigger than 36. So it does work. How many times did it take? It took 2 standard deviations. Alright. Only a few more. 19. A set of data with a mean of 12.05 and a standard deviation of 4/2 is normally distributed. Find the values that are 1 away from the mean. Oh, that's easy. Go ahead and add 1 standard deviation. So you get 16.25. And go ahead and subtract a standard deviation. And that'll give you the lower end. So these are 1 number away. Think of them as kind of the numbers you would have on the bottom of your bell curve, right? Okay, average height of a man is 70 inches with a standard deviation of 2.3. Sketch a normal curve, labeling the horizontal axis at 1 and 2 standard deviations away from the mean. So here's the mean, 70 inches. We're going to add our 2.3 inches every time, right? So 1 away is going to be 72.3. 2 away will be 74.6. We'll go the other way. You're going to subtract 2.3. So you get 67.7 and 65.4. Hopefully you can see those numbers. Anyway, you put the percents in here. And remember, I told you those should probably go on your note card. Okay? That's all I want. 21. A local bakery makes chocolate chip cookies. Number of chocolate chips in the cookies is approximately normally distributed with a mean of 11.4. Maybe I should draw the curve. Mean of 11.4. Standard deviation of 1.3. So I'm going to basically go ahead and draw the whole curve. Okay. So this will be 12.7. This will be 14. This will be 15.3. All right. We'll go the other way. 11.4 minus 1.3. That'll be 10.1. And then 8.8. 7.5. And then we have percents. Okay, I apologize, hopefully you can read this, but you should know by now what's going on here. Okay, all these percents. Now, what percent of the cookies have between 8.8 and 14? So, 8.8 and 14. Well, basically, what percent lies between those red bars? You just add them up. Well, basically, it's 2 standard deviations. And I told you in class, 2 standard deviations should be 95%. Okay? Very, very simple. To win a prize at the county fair, the diameter of a tomato must be greater than 5 inches. The diameter of a crop of tomatoes grown in special soil are normally distributed with a mean of 3.8 and a standard deviation of 0.6. Okay, so we'll go on to a different page here so that we can, whoa, that's kind of weird. Mean of 3.8, standard deviation of 0.6, so we have 3.2, we have 2.6, we have 2.0, we also go up by 0.6, right? It was 0.6, wasn't it? Yes, it was. So we have 4.4, and we have 5, right? And we have 5.6, okay? There are percents. Notice how it's the same percents every single time. That does not change. Anyway, if greater than 5 is our winner, so red bar in that way, well, the only way that's going to happen is 2.5% of the time. You just add up those 2%. Okay? Whew! Good luck studying for this test. If you need me, you can always holler, Twitter, email, or you can come in early in the morning and I will be here to help you. All right? Good luck studying and have a good evening.